Welcome to the joy of coding.
Hello, and welcome to episode 91 of The Joy of Coding. My name's Mike Conley. Going to be hacking on some Rust Firefoxy stuff today. It's going to be a little low level. I'm still sort of figuring my way around Rust. If you've been watching the past couple of weeks, it's going to be more of that, but hopefully a little more focused. We'll see. I hope to make more forward progress this week, more than we've made in the past. So let's get down to business. Where are we at here? Let me share my screen. Boop, 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 boop. Okay, today is February 15th, 2017. A reminder that no plan survives breakfast. I do hope to write some Rust today, and I do hope it goes well. I hope it goes according to plan, but it might not, because that's reality, and I haven't planned anything really. I'm going to be tackling these problems as they come up. I'm going to be, I haven't got like a pre-scripted solution or anything, and it's a little bit difficult to sort of put on a show while also like thinking out loud and solving a problem. So you're gonna have to bear with me. There's I'm solving these problems or attempting solutions on the fly. So it's possible that we'll write stuff and it'll get thrown out. I know there was some commentary, there was some feedback from my last episode about Rust where one of the questions I ask in my rate this episode form, which you should totally fill out, is there anything you'd like to see less of? And the response was spending 2 hours of Rust coding resulting in nothing at all, because that's exactly what happened. We wrote some stuff in Rust. Actually, it was interesting. I was messing around with structs and traits, and it didn't actually end up going really anywhere, and in fact I've tossed out most of that code, and that sometimes is reality. I'm going to try to avoid that today, but no promises, because no plan survives breakfast. Let me just quickly check and make sure that I am recording and my mic works and that I'm streaming across, let's see, Facebook, I got YouTube, I got Twitch is going, I got Air Mozilla is going, so I think we are in good shape. We're streaming. In case you want to watch this on any of those other channels, I've been posting to this subreddit called Watch People Code, which I think there's a link to down here in the links section. And in the post itself, there's a link to all of the different ways you can watch the stream. If it turns out you don't want to watch it on Air Mozilla, but you want to watch it on Twitch, there's a link to my Twitch channel, and you can watch it there. And you can also this document that I just dropped that link in. This document, the agenda, so to speak, is available to you. It's in the additional links section. If you're watching this on Air Mozilla, if you scroll down, there's an additional links section. If you're watching this on YouTube, it is in the description for the video. And if you are watching this on, let's see, Facebook, unfortunately, there's no way I can add a description to the post, so I post the agenda after the fact. Sorry about that. And if you're watching this on Twitch, I'm about to drop it in the Twitch chat. So here's the link to the agenda. I don't remember if I just did this, but copy it to the clipboard, and I've just dropped it into the Twitch chat. And also the link to rating the episode. I'm also going to drop that in the Twitch chat. You should totally rate this episode and let me know how I can make it better, because I read them all. I read all the ratings. Before we get started, I also want to give a quick shout out. I did this last week. I'm doing it again to a good friend of mine, Dennis, on the web compatibility team. He's on the team that tries to figure out why stuff is like why websites break in some browsers but not others, and try and like improve compatibility between browsers. Maybe a website was designed for only one type of browser, or maybe they're doing something just a little weird with some old like, I don't know, prefixed styles or something. Like basically any kind of cross-browser compatibility issue. Dennis is part of that team, and he started to do this series similar to The Joy of Coding called The Joy of Diagnosis. This is episode 0. I believe it's going to be a semi-regular sort of series, and you should totally check it out if you're interested in seeing what goes on when we try and figure out what's broken across different browsers. And there's already some feedback here. If you read this, it says, "Incredible! I really enjoyed the video. I look forward to the next episodes." So that was 4 days ago. As a great endorsement. I'm giving it an endorsement as well. You should totally check it out. So I'm done plugging that. Let's get down to business. We're going to be writing some Rust today. I just Rust is not a language I'm super comfortable with. That's why it's kind of going so slowly. I'm learning it as I go. I'm more comfortable with JavaScript and C++, which Gecko is traditionally written in. Rust we're starting to use more and more in the browser, and it's something that I hope to become really good at, but I'm not there yet. I can read it. I can sort of read it, but I'm having difficulty writing it and getting used to it. So let's try that today. I've also switched back to Sublime. Last week I was using the Atom editor, and there was like someone suggested it in Twitch a couple of weeks ago. They said you should try Atom because Sublime, at least the version I had, didn't have Rust syntax highlighting. So I said you should try Atom, and I tried Atom, and it was okay, but it was too slow. I didn't like the performance characteristics of it. Just like it felt sluggish, which it pains me to say because I know that a lot of it's built on top of web technology, and hopefully the web will just get faster. Hopefully I hope to use Atom one day because it's built with web technology like JavaScript and CSS, and so we should strive to all use Atom as people who love the web. But right now it's too slow. So hopefully faster soon. Okay. So what I've done, I've switched back to Sublime Text. I actually bought the third one, Sublime Text 3. I bought a license, or rather Mozilla bought me a license because I requested one, and they're nice like that. And so now I've got Rust syntax highlighting. So I got what I wanted, and we can keep going. Okay, so what am I doing? What am I doing today? We're looking at some Rust, and it's sort of the same problem as before. I've got this thing. We have this like special language in the tree in Mozilla Central called IPDL, and I want to convert that. Like the whole point of that language is to take care of writing a bunch of boilerplate that's used to set up communications across pipes between processes. So you write an IPDL file which declares a communications protocol between processes. Then the IPDL parser, or compiler I should say, converts that IPDL file into a bunch of boilerplate C++ that we then like include in subclass in our code. So the compiler takes care of, like the IPDL parser compiler takes care of doing all the sort of boring generation of code, and that's what we're working on. Traditionally, that was written in Python. It's written in Python. It exists in the tree as Python. It's very complicated Python. We're hoping to rewrite it in Rust, both for more speed and just to simplify it, because right now it's too complicated. It's hard to hack on. So where are we at? Well, we've got the parser done. This is something that I've been working on with several other developers at Mozilla, kind of on the side. There's this sort of library for Rust called Lallerpop. It's a utility that you use to write a parser, or yeah, to parse a certain syntax. And so Lallerpop, the syntax has all been laid out. We've sort of defined how IPDL works as a syntax. And so now we're at the state, and this is the part that I've taken some responsibility of. We're at the point where we want to take the AST, that's short for abstract syntax tree, I think. Syntax tree, yeah. An abstract syntax tree. So that's the stuff that we converted the IPDL file to, this data structure. We want to turn that into C++ using Rust. So it's lots of different stuff going on. And what we've got here in this file, we're already at the point where, like, parser parse, we're taking in some directories that we're including, and some like that might have some include files in them, and then we have some file names of IPDL files that we want to parse, and we pass those over to the parser. So there's this module called parser, and we call parse on it, and what we get are maybe TUS's. TU is actually short for translation unit. Is that what it's called? Translation unit, yes. And translation unit is like the top level node of an IPDL file, the AST. At the very top, there's a translation unit. And inside that, there's all this like stuff that we want to like convert into C++. So we hopefully get back a translation unit, And then now what we're doing is we're going through each of the translation units, because we might have several, because we may have parsed several files. We want to go through each of these translation units and turn them into C++. And so what I'm doing is right here, this is something I wrote the other day, is I'm iterating over the translation units. And the translation units it's basically this hash map between a path to the IPDL file that we generated, or that we read in, um, that we read in and parsed, and then the TU is the translation unit for that file because there's only ever one per file. And now I'm calling this function I defined called compile translation unit, passing in that path and the translation unit, and we're getting something back. Excuse me. We're getting back an option, and in Rust an option is something that's in one of two states, either some or none. And if it's some, we unwrap that some because it's our result, and if it's none, then we error it out. Like we handle that case. None means, you know, I wanted to be like, you called me and I didn't give you what you wanted, or I'm returning none essentially, as opposed to null, because there is no null in Rust, really. Um, and I chose an option just arbitrarily. There's something similar in Rust called result, which is like okay and error, as opposed to some and none. Um, and I think they have slightly different characteristics, and I think result wraps an option, but right now we're using an option because that's the way, I don't know, that's the way compile was written. If we want to switch to a result down the road, we can do that. Um, I'm still learning, so maybe an option is not the right choice here, but that's what we're going to go with now. And if during review we decide we want to do something else, we'll do something else. We have to move forward. We're trying not to get bogged down, so we're going to move forward and try and write some code this time. So let's get down to business. Compile translation unit is taking in the path buffer, which is the path of the IPDL file, and the translation unit, and what it's going to return. This is a little complicated and it's kind of long. I have a feeling that I should be wrapping this around for better readability, but for now, what we're returning is a tuple, or tuple, I don't exactly know how to pronounce that, but it's a two-element thing, not a vector that can grow or shrink. It's like a fixed-sized pairing of things, and the first element of that pair is a mapping between a file name that we want to write to and a string of the C++ we want to write to that file. And then the other thing, in the second element of that tuple, is a vector of strings. And why do we want that? Well, if you go back a couple of episodes, we started by running a very simple IPDL file through the Python compiler and looking at what it spat out. And it spat out a couple of things. So this was the empty IPDL file that we put through the compiler. It's an empty protocol. That's what it's called, empty. That's the name of it. And we say that the child can send an async message called message. And what's generated is like child empty.h, like so that's sort of the convention. We'll produce at least the following files: empty.cpp, empty.h. I'm sorry, I can't like expand this. I can't make this grow, I don't think. Yeah, I can only make the over here grow, but empty.cpp and empty.h, because that's the sort of base common stuff that both the parent and the child in the IPC communications, I guess, a relationship will inherit. And then we have the specialized stuff. Like in this IPDL file, only the child can send this message called message. And so empty child gets this, I believe there is a function that we can inherit called, what is it? Oh, sorry. I misread this. So child receives an async message called message. So empty child has this function on it that we have to implement if you were to create a subclass of empty child called receive message. And parent, empty parent, has a function called send. Where is it? Send message. Where would it be? Send message. Yeah, right there. Must use send message. And that's actually already implemented for us because that is um, send message is something that you you don't have to implement yourself. The boilerplate implements it for you, but the receive, like what you do when you receive that message, that's something that you as the implementer of a protocol need to sort of sort out yourself. So we get an empty.h, an empty.cpp, an empty child.h, an empty child.cpp. We get an empty parent.h, an empty parent.cpp with a bunch of this boilerplate. And then we get this other stuff. We get this thing called IPC message start.h and IPC message type name. And these two files are used to like I believe they're used at the global inter-process communication layer to classify what kind of messages are coming in. Because in the end, there's a single switch essentially that's looking at the messages coming in between processes and saying, well, who does this message belong to? Because each message will come in kind of with an identifier, and that's what these two things do. Is map the they'll map the message identifier to where it needs to go, I believe. Um, I think that's how it works anyways. So this is the thing that we actually need to spit out, as well as like these two files are important to spit out. And that's interesting because this is sort of an aggregation across all of the IPDL files that we parse. We're going to produce a single IPC message start and a single IPC message type name, and then also individual like child and parent and base class pairs like .h and CPP pairs for each of the protocols. So there's all of the individual protocol files, the CPP and H files for the child, parent, and base, and then there will be, after all of that, there's a single IPC message start.h and a single IPC message type name.cpp. So that's what this vector string is for, because what I'm going to do, and hoping I can do this episode, is every time we call compile translation unit, I'm hoping that what can be returned is a set of messages that the translation unit will send back and forth, and then we can sort of uh, grow this table, grow a hash map, or it's more like a set of these messages. And after we're done going through all these translation units, we should have an accumulation of all the messages that can be sent back and forth. And then I'm hoping we can then dump out our two special files here, IPC message start and IPC message type name. And that's what I'm hoping to focus on today. Not so much the empty, like the parent and child and the base, but the global message start and message type name files, because I feel like that's the simplest step forward. So let's try that today. And maybe we'll even get to write a test. So that was a long-winded explanation. Hopefully you get a sense of what we're doing today. You'll notice that even though I'm accepting the messages, so this is compile translation unit, I'm matching the return result of compile translation unit, and if it is something as opposed to nothing, as opposed to none, if it's some, then the result will be that tuple I was telling you about, and I'm doing a deconstruction here. The first element I'm calling mapping, and the second one I'm calling messages, and I'm not doing anything with messages in here. This will still compile though. Let me show you. And bump up the font. So this should compile, if I'm not mistaken. Oh yeah, I'd already built it before, and let's run the tests. Yes, the tests run, and it still works, but we don't do anything with the messages. What I want to do is accumulate more of these messages. And I'm pretty sure it's straightforward to get the list of messages from a translation unit. So let's take a look at the AST. The AST this is the structure that we are creating whenever we parse the IPDL file, and there is something called protocol. Oh, yeah. There's a protocol, a single protocol for a translation unit. There's all this like meta information, but then there's this protocol, and it's got a namespace and a protocol, and we'll take a look at protocol now. And protocol, if I look at the structure of it, has all these messages, and that is what we want to get at. So inside our compiler, we're going to take this translation unit that we were passed, and I'm going to see if we can get a reference to these messages, this messages structure. And so there'll be this like message declaration thing, and it's got an identifier and some semantics, in and out params. And I don't think we need most of these things. I think we just need the name. And the name, coupled with like some other information maybe from the top level translation unit, should be enough to flesh out the vector that I'm hoping to pass back to the parent about what we're going to drop into this IPC message start and IPC message type name file. So a lot of this I'm gonna just get like commented out at first because I don't want to even think about it. Um, and result is going to be like this hash map. It's going to be an empty one. What I really want to deal with is this vector that I want to pass back to the parent. So I'm going to say that it is so like let messages equal vector, an empty vector. And I'm going to be adding things to this vector, so I have to make it a mutable. This is a mutable variable because things in Rust are immutable by default. And so I'm going to, it's possible that I don't even need to like iterate the messages and append each one. Perhaps I could just do a straight copy. I'm not entirely sure yet, but we're going to find out when we start messing with this stuff. So this should still build actually. Or test, I'll run test. IPDL test. Oh, it doesn't because I cannot infer type for underscore. What is underscore? Let mute messages equal a vector. Maybe I have to tell it what kind of vector. I think, is there another place where I've used vec? I think I saw it some other place. Vec. How do I create, do I have to create a new vector? Let me take a look at some Rust example code. So a great place to look for Rust example code from people who know it really well is the Servo project. That's the browser project. Let's see if I can find an example of vector being used. So yeah, let keyframes equal vec. Now maybe it's because I need it to be mutable, and that's why it's let mute that one. Let mute buffer equals vector, and then open parentheses and close parentheses. Maybe that's what I want. Instead of saying let mute vector, I've got these square brackets. Maybe I need to say open close parentheses. I'm not entirely sure what the difference is. I'm guessing that it means just like create an inline empty vector. I don't know why the parentheses would make a difference here, but it still doesn't like it. It cannot infer the type. Type annotations are generic parameter binding required. This error originates in a macro outside of the current crate. So this is error 0282. So let's see if we can look that up. Maybe there's an example. Rust vector E0282. Just gonna error index 0282. Type inference did not result in one unique possible type. So maybe I need to like give it a hint. So like let mute, then maybe I have to give it a type. Let mute messages, so it's going to be a vector of string type string. Maybe it'll like that, and I'll put these square brackets back. Is that enough to appease the gods of the Rust compiler? It is. It is enough. So I had to give it a hint. I had to tell it, look, you're going to be a vector of strings, yo, and like I'm setting a type. Okay. That seems reasonable. So I guess I don't need those anymore. It's interesting. I wonder when it can do type inference and when it can't. I'm not exactly sure yet. Let's see. So the next thing I want to do is look inside this translation unit, and I'm gonna have it. Let's see. With the AST, this translation unit, I want to get the protocol to. So I want to say like let protocol equal tu dot protocol dot unwrap. Um, or can I say expects should have had a protocol? Now expects I think will cause us to raise an exception, and otherwise will unwrap the protocol. So that way I've got like some error checking built in. Expects, maybe it's supposed to be expect. I think it might actually be expect. Cannot move out of borrowed context. Aha, so I've heard of this sort of thing before. I believe this is the borrow checker is yelling at me. So let's look at these in the Rust error index. You tried to move out of a value which was borrowed. So in this example, we've got a structure called the dark night, and then a function on it called nothing is true, and then a main function that says give me a ref cell on the dark night, and then borrow it, and then call it. And it says, no, you cannot move out of the borrowed context. Nothing is true method takes the ownership of self. However, self cannot be moved because borrow only provides a reference to the dark night, which is a borrow of the content owned by the ref cell. Fixed there, you have three choices. Try to avoid moving the variable, somehow reclaim the ownership, or implement the copy trait on the type. Into inner. Moving out of a member of a mutably borrowed struct is fine if you put something back. Maybe I should be looking at this in the book. Borrowing. So in this example, we have a function that takes two vectors and it borrows them. I think that's what that means. It's passing, like, to me, my C++ is like, oh, you're taking a reference. But I believe what it means is borrow in Rust. Instead of taking vector I32s as our arguments, we take a reference, and instead of passing v1 and v2 directly, we pass in these. We call this as a reference rather than owning the resource. It borrows ownership. So that means that in our compiled translation unit function, we've borrowed path buffer and translation unit. Okay. So far, so good. And binding that borrows something does not deallocate the resource when it goes out of scope. That's good. That means after the call to foo, we can use original bindings. References are immutable like bindings. The vectors can't be changed at all. So for some reason, Rust seems to think that whenever I call .protocol .expect, I'm like somehow mutating it. Let me see what happens when I do. Oh, I wonder if, no, I don't know what that would be. If .expect will like attempt to mutate the translation unit. I'm going to let's see here. Two protocols should have had a protocol. What do we do? What do we do? Well, can I just say, get a reference to the protocol? I think I was trying that a second ago. No, it doesn't like it. Oh, sorry. I need to put a semicolon there. Because apparently, to prevent move, use ref protocol. Because whenever I say a protocol is tu.protocol, I'm saying that it is moving. I'm moving it somehow. So if I say let ref protocol, can I do that? Cannot move out of. But if I do that it likes, but I can't call dot expect on it. Can I call ref protocol real? And it's just, that's a bad name, but protocol dot expect test. So that, no, it doesn't like that because I'm moving it out of the borrowed context. This is called fighting the borrow checker in Rust parlance. Um, so let's see. What do we want to do here? I've got a translation unit and I want to manipulate. I've got a reference to it. And I need to essentially, I want to get at the, can I just like get at the protocol itself? I got a feeling it's not going to like that because it cannot move out of borrowed content. I got a feeling this is a super common problem. This takes self, not a reference to. This means the student won't be available after the call in this place to get it back the previous. I could clone it. Okay, so here's an example. I have on the Stack Overflow question. Let's see if this applies to us. So we have an enum, a val1, val2. We have a structure. It takes a field 1 of type myEnum1 and a field 2 of string, and I have a function that will take a structure, a string, and a string, and the function 2 which takes borrows one of the enums. And then the function fn2 receives a reference to myEnum1 as a parameter, but the struct1 contains an owned myEnum1. Struct1 contains an owned. This means that you are actually trying to turn a reference into an owned value. Reference into an owned value in function 2. And that's saying you might want to try cloning it. Are any of these clonable? Qualified ID, yes. Namespace. Compress does clone. Send semantics does clone. Nesting does clone. Priority. So a bunch of these do clone. Maybe all of them do clone. No. Direction does clone. Location identifier, but like protocol does debug. It does not do clone. Interesting. So there's another function in here, or there's a type check.rs. I wonder if it does anything. I can use it as an example, like protocol. Do we ever see it? Doing any kind of manipulation of a protocol? Protocol type def. Messages, managers. Not really. something. I don't know if that's very useful when trying to transfer ownership. This is against the grain for us. You cannot transfer ownership of something borrowed because you don't own it. You shouldn't borrow my car and then give it to first person on the street. This is still true even if you lend the car and allow you to make changes to it. You cannot move head out of mute self into a new node because that leaves the linked list structure. You can use option take to delete the variable where it is changing it in place without moving it. It's to take ownership of the struct instead of borrowing it. So what if we take ownership of the struct instead of borrowing it? So check translation unit. Oh, sorry. Inside compiler. Got these translation units. So maybe I should pass it like that. Mute translation unit. Can I do that? Oh, it shouldn't really be mutable. But pass the translation unit and compile translation unit tu in TUs. TUs is something that I get out of maybe TUs, which is from parser.parse. Parser.parse is going to return me back some translation units. So maybe that was my problem. I shouldn't have been passing in a borrowing of translation unit. I maybe can pass it in directly. And then will it let me do this? Let's find out. Expected a structure and instead found a reference in compile translation unit. Oh. Can I do it that way? I'm guessing here. Expected reference found a structure. Oh, okay, so that's what I want to do, I guess. No. Value moved. Move occurs because IPL path does not implement the copy trait. So maybe I pass in a clone? I'm really just guessing here. So it likes that. And because IPDL path is a path, it's called a path buff, maybe what I can do then is I'll just pass in the borrowing of a path buff. It'll like that. Okay. Instead of cloning it. Okie dokie. And then we're going to, so we've got our translation unit, and it looks like we were able to get our protocol. So that's good. So I can go back here. And I think what's going on here is Rust is doing exactly what I want it to. Panic that call option unwrap on 323 inside option. What? What? Why did I fail? I failed somewhere. Probably here. Should have had a protocol. Probably panic here. I'll bet that's the story. Sorry, I'm just humming some George Harrison. So where did I panic here? Panic. I try and panic, and yeah, I should have had a protocol whenever I attempt to parse IPDLH. So the translation unit might actually not have a protocol if it's an H file. Okay. So I think I have to have that. So it might not have a protocol. The translation unit might be a header. So we cannot say whether or not it's actually got for sure whether or not it's got a protocol or not. If it does, though, I think maybe so. We need to not expect it. We have to check. So see if this translation unit has a protocol. Note that .ipdl files have protocols defined in them, but ipdlh files do not. Okay, so let's say a protocol equals, we're going to see if tu.protocol, and then on an option, because this is an option, Rust option, we're going to look at the Rust option spec here. I think there's like some kind of is sum, and we'll return true, is sum. We can get rid of these extra braces. If is sum, then we're going to get the protocol, and then we're going to, so that should compile. It still failed, and I think it's because I accidentally kicked off the compiler before I'd hit save in the file. So this should not fail, I don't believe. We should not panic here. This should all pass. Yes, that all passes. Okay, good. So if we have a protocol, I should say, if we have a protocol, then we should be able to get the protocol's messages. Messages will be a vector. Messages equal protocol dot messages. And then what are these messages? It's a message declaration. We're going to just, let's see what happens if we just print out the message identifier. An identifier, struct identifier, is an ID and a location. So I'm just going to say ID. So for let, how do I iterate again? For, oh, I just message of, is it of? In. Message in messages, and then I can say print line my name. I have a message named, and then that, and I'm going to pass in message.name.id because a name is a identifier and the ID is the string. Okay, so let's see what happens when I do that. I'm also going to no capture. There's going to be a, oh, doesn't like that. Argument never used, message.name.id. Argument never used, but I'm using it. Message.name.id. What? For message in messages, message.name argument. Can I just like do that? Oh, it's because I'm using old style printf format strings. I should do it like that. That's how you format strings in Rust. It still doesn't like it because no field name messages on type, and then what we have here is a tuple of namespace and protocol. So I should say it's not, it's a protocol tuple. Messages equals protocol tuple, and then I think I can just refer to the first one. Actually, I want the second one. protocol tuple dot messages. I think that'll work. You to access tuple elements use tuple dot one. Interesting. That's how you access tuples. That's kind of weird, but okay. Okay, so I have a message named child message, parent message, both message. Good, 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 good. So this works. Message, sync message, interrupt message, message, message 2, message 3. So good, we've got the names of the messages. That's exactly what we wanted. And now we need to like put them in this collection. And I have a feeling we're going to want to prefix them maybe with the name. So like the way that these were generated over here is it's like namespace and then the message. So we might need to do the same thing. We'll concatenate the protocol's namespace and then the message. And the namespace is something that we see on the translation unit. Yeah, there's a namespace. Yeah, and a namespace is... Oh, wait, hold on a second. A namespace also we get from the protocol. Namespace. And I wonder if, like, can there be nested namespaces? Namespace, and then a protocol namespace. Can we have nested namespaces? Let's take a look at how the Lollipop works. Namespace. The canonical namespace, the translation unit, and then namespace thing. So there can be multiple namespaces. I don't know how often that's used, but it sounds like we can have several namespaces here. And so what we want to do is want to probably take the top level namespace, concatenate it with the the protocol namespace, and then the message. So top level namespace. Top level namespace. How do we get access to that? That's on the translation unit. So let top level namespace equal tu dot, and then I think I just like call namespace on it, and then I can get the a namespace. Struct namespace has a name and namespaces. Why are there namespaces under a namespace? What? Namespaces. Why can there be other namespaces? Add outer namespace. Oh, we can call... Oh, that's interesting. String from namespace. Self namespaces. Insert 0. String add outer namespace. When would that be used? Add a, so if something is namespaced, namespace thing, we might already actually have namespace insert. If we look at, we might already have like a collection under namespaces, and we don't need to actually, we won't need to do the concatenation ourselves. We're going to have this vector on the namespace of the protocol. Okay, I think that's what I'm seeing here. Okay. Okay. So like we get we're gonna get the protocol's namespace. Let namespaces equal protocol tuple 0. I think that's what it is. Protocol tuple is what is under translation unit.protocol, and it is a tuple of namespace protocol. And a namespace, we just determined, has other namespaces, but also a message. That's what it is, a message. So protocol has a namespace protocol, and then a protocol has a set of messages, and a message declaration doesn't have a namespace. Okay. What are things that have namespaces? A translation unit, a namespace has a namespace, or can have a collection of namespaces. And that's interesting. Okay, well, that's crazy, but all right. Um, this sort of like pattern of option namespace, I'm curious about how often we're going to get namespaces back from things we're calling. It's not too often. Okay, so the 0th element is a namespace. Namespace dot namespaces. Is that what it is? Namespace. Oh, that word is losing all meaning. So that should be a vector of namespaces now. I want to concatenate all of those together. But first, I'm going to say for namespace in namespaces with namespace dot name. Is that? Oh man, yeah, which is an identifier dot ID. That's crazy. Okay, so let's see if it likes that. Nope. Did you mean namespaces? I think I may have. I think I may have gone too deep. I think that's what I meant. Unknown field on the namespace. Namespaces. It's an oh, it's just a string. Oh, okay. So maybe I can just do that. Use of moved value namespace. Move occurs because namespace is type string does not implement copy. For namespaces dot clone. I guess I'll just do now. Note move occurs because namespace is type string does not implement copy. Point use of move value namespace. This is the borrow checker again. It doesn't like that I'm iterating this set of namespaces. Is there, maybe there's something simpler I can do too, like rust join vector of strings. In Rust, slice concat x join is available. So, oh, I can just do dot join on a vector. Whoa, really? So maybe I can just do with namespaces. Then I'm going to do that, and I'm going to do namespaces dot join. Let's see if it likes that. Whoa, it might like it. That's crazy. Vector of strings, I can just call dot join. Traditionally, C and C++ have never had amazing, super amazing support for strings. Not a whole lot of namespaces being printed out, by the way. I'm just seeing like emptiness. No namespaces. So maybe let's take a look inside our test files here. Yeah, there's one called endpoint declaration, and it should have a namespace called Mozilla. So if I do target debug IPL parser include dot and then what was it called? Namespace basic. Unrecognized option I. Yeah, I meant capital I. I have a message named message with a namespace is basic. Okay, well that's good. Now namespace basic. Can I do namespace foo? Can a protocol can I do that? I got a feeling it's not gonna like that. Yeah, doesn't like that token. But I wonder if I can do like nested namespaces, like namespace foo namespace bar. Yeah, basic foo bar. It's working. That's good. That's good, good, good. Okay. That's exactly what I wanted to see. Um, so we've got our namespaces. And I'm going to join them with nothing. And then print line message, and then that, and that, and that is namespaces message. I'm actually going to do that in here. So slightly different, slight variation. Cargo build. Whoop, doesn't like that. Wants the macro symbol, which is an exclamation mark. Doesn't like that either. Message dot name dot ID. That's what it wants. How are we doing for time? Hey, I think we're making forward progress. It's slow but sure, and steady wins the race. Seriously. I don't know if anyone's actually watching. Do I have any viewers? I got some viewers. Not too many. I got some stream health here. I got 4 viewers. All right. Hello, you viewers. Good to see you. 4 viewers there. I'm vanity vanity checking my viewer count because I'm so vain. So now I'm gonna run that manual test again. Target debug IPL parser dash I. Ooh, Devil Tiago Chrono says yes, you have some viewers. Kappa. That's what you folks say on Twitch, right? And now tests. Okay, and then what was it? Basic namespace. Namespace basic. That's the one. I actually don't want to include it. I want to compile it, so that's what I'll do. Message. Basic message. And basic, I think, is the namespace. So, hey, I think we're okay. Let me just double check. Let's see if there are any other things with namespaces in here. We should write some like some tests at some point. Union namespace. What's union namespace got inside it? Union namespace kitties has okay. puppies. So it should come out with puppies message. Um, union namespaced. Puppies message. Great. Dennis says he's watching via AMO. Airmo, right, lurking in the Twitch chat. Probably mess up your count. Maybe. The fact that Dennis, that fellow I was telling you about, the joy of diagnosis, he is actually watching this right now. I'm so flattered. I'm blushing internally, and it sounds like he's got both Twitch and Airmo open. So he's a super fan. He's got like me in stereo, probably with a little bit of delay. So the fact that you can make sense of that blows my mind. Although maybe you're just talking about the chat. That's probably more realistic. But great to see you, Dennis. Thanks for being here. I really dig your show. Um, what are we doing? So I think we've got something that kind of works. We've got our namespaces that we've joined all together. We've got our list of messages. And now what we're going to do is we're just going to spew them out. We're going to concatenate them together basically like we've written here, but we're going to put them inside um, this. Oh, see, I'm shadowing. I've got two things named messages. I'm going to message strings is what I'm going to call it. Yeah, I'm going to format. Can I do it this way? Format, exclamation mark that. We're going to join them together. And then I'm going to say message stirs dot. And then what is, I think it's like standard Rust vector append? Or is it pushback? Or what is it? When you add to a vector, what do you do? What do you do? What do you do? Push, just push. Push. Now I might need to do something like dot to owned there. Let's see if it likes that. Will it build? Amazing. Yes, it will. So I'm going to play a sound in celebration because I don't normally play sounds. Twitch supports IRC, so I'm not actually watching your stream. Actually, that's true. Dennis, good call. I'm also connected to Twitch via IRC. Right on. Um, cool beans. Played some sounds there because I'm pretty happy. I'm actually making what feels like forward progress. Hopefully I don't end up just ripping this stuff out later. But now I've got these message strings, and now I can return this vector. I think I can return that, and it should like it. Yes, it does. So, if that's true, then I should be able to construct, I should have all the information I need to construct this. Um, and maybe even this, which is great. So, let's see. Messages. And then I want to concatenate. So I've got like let mute message strings stirs equal, it's going to be just another vector of strings, I guess. Vector string. All message strings is what I'll call it. And then I'm going to say all message stirs extend messages. Will you build that? Amazing!
Oh, yeah.
I'm on a more reliable network this week, so I have a feeling that's why my sounds are actually working. Are you a programmer or do you just have fun programming? Asks Devil Tiago Kronos. I'm a programmer and I have fun programming. Why not both? So I'm a professional software engineer. That's what I do for my day job, but I also have a good time doing it. I work for Mozilla, the creator of Firefox and a bunch of other cool stuff, including Rust. Or like I can't say we created Rust. We sponsored it, and now we're growing Rust. The creator of Rust is actually a fellow named Graydon Hoare. Brilliant software engineer is now at Apple, I believe. But now the Rust is guided by a community of people and sponsored and supported by Mozilla. So that's what I do for a living. I work on the Firefox web browser, and right now I'm working on a thing that helps us build that more reliably, I'd say. So that works. We'll have constructed all these message strings, and now I want to like, I'm going to say, at this point, I need to ensure that somehow we didn't accidentally, uh, um, wait, IPC message start.h and IPC message type name.cpp are, whoops, are, why are you autocompleting that? Are two special files that we'll create after iterating all translation units. We'd better not have parsed any or compiled any translation units that will result in files with those names. Okay. Devil Tiago Chrono says, "Awesome, that's the kind of dream job everyone wants. Doing what you like." I absolutely have a dream job. You know what? I don't want to go off on a tangent here. We're actually on a roll, but I'm so privileged to be able to like wake up in the morning and enjoy my job. I've been doing this professionally for about 5.5, almost 6 years now, and every day I wake up and I'm happy to go to work. I'm happy to do my job. Um, you know, the Mozilla mission really resonates with me. The people here, I really enjoy the community, the wider community, and also the paid staff who work with me in the office here. But also like just the puzzles and problems. Like this is a cool problem that I'm working on. I'm really enjoying it. So and they like I just sort of made up this show, The Joy of Coding, and I can just do that. There's no problem with that at Mozilla. No, they're like, no, you have to get approval or anything. I just do it, and people seem to dig it, so I keep doing it. So I take a chunk out of my day and do it. So I want to make an assertion. So is there like a Rust assert function? Can I put that inside anything besides tests? Ensure that this will invoke a panic. Yeah, that's what I want to do essentially. Assert. And I'm going to have these two be special names. So there's a way that I can like have special names or special strings, like static strings. Yeah, this is it. And I'm going to call it the IPC message start file. So message start file, message start header. And I'm going to call it IPC message start.h. And I'm going to have another one called, oopsie daisy, a message type name, message type. And what does it do? Like a message type. What would you even call this? This is like a message type name. Message type name. I don't know. There's probably a better name for that. Message type. Message type definitions, and I'll say IPC message type name. So these are static strings. And now I'm going to make sure that after doing all that business that they are not already inside the what we're going to be writing, a result, which is a hash map. Now here's the thing, I'm writing this hash map path buff string. I think that's wrong. I've just thought about it. I actually think what we want to return is string and string, because path buff is useful if I want to know things about the file path where the file came from. But at this point, I just want to have a file name and the contents of that file, because there's an argument to the IPDL parser that says put things in this directory. So I don't actually need to know the rest of the information about the path at this point. I do whenever I compile it, but when in order to go and get the file and parse it and stuff. But whenever it comes to writing it out, I just need to know the file name. So let's say that when I go through this, I compile it. Compile translation unit shouldn't return result is some hash map. Yeah, so for now it's just going to be a hash map, and that hash map will be of strings and strings, not of path buffs and strings. So that's important. And then I'm going to make sure that a vector, I need to check for whether or not a vector includes a certain value. There's a vector class documentation. I want to check to see whether or not it has a thing. Capacity reserve, that's memory stuff. Truncate, as slice, set length, swap, remove, insert, remove, retain. I want contains. Is that contains? Clear. Is there contains? Yeah, it's just contains. Okay. And then I have to pass it a borrowed value. Okay, so assert that result, I'm going to actually call this files to write instead of result. Files to write. Oopsie daisy, come on, come on, come on. Assert that files to write dot contains not, it doesn't contain, and then a reference to that string. I think I can do that. Should not have the message start header yet. Can I do that? Will you like it if I build that? No. File, did you mean file exclamation mark? Sorry, no, that's right. I meant file name. Unresolved name, result. Yeah, that should be files to write. And then contains, found for type. It's a hash map, not a vector. Silly me. It's a hash map, not a vector. So there should be something that's like has key or something with capacity, with hasher, with capacity, capacity. Keys, values, entry, length is empty, drain, clear, get, contains key. Yeah, that's what I want. Contains key. And maybe I don't need that part. A lot of warnings about stuff I'm not actually using yet. That's okay. We'll deal with those down the road. That worked. Now, what if I were to accidentally, let's put something in here. Let's say instead of result, files to write is what I'll call that. I'm going to say files to write. I'm going to add it. I'm going to set function put, function put. How do I add something to a hash map? It's insert. Insert. Then I'm going to say message type, or yeah, message message start header. Boom. So that should explode. Struct message found stir. Huh. Files to write equals hash map string. Is it better if I'm more explicit there? Yeah, so found reference, I need to like do to owned and then to owned. Basically create string copies, I think. So this should cause an explosion. We should panic because what I've done is I've put the thing that I expect not to be in the vector. I'm expecting this to explode on me. Yay, panic. Should not have the message start header yet. Good. So that's what I wanted. That's working as expected. I want to say the same thing for message type definitions. And now I'm going to construct those two files. So files to write insert message start header to owned. And then I'm going to pass in the like compile message start header, and then I'm going to pass in our all message strings to owned. And then I'll do the same thing for message type definitions, compile message type defins to owned. Okay. Okay, so now I need to like define these functions. This is going to be a function that takes in our vector of messages, right? It's a vector of message strings. And it's just going to do some insertions. So I'm going to say we can borrow it. Messages, all messages. And we're going to borrow. And what we're going to return is just a string. So I'm going to here I'm going to just say return hey, I did it to owned. And then I'm going to do the same thing for the other one, except instead of message start header, it's going to be that thing. But it's the same. Hey, this is the message start header. Hey, these are the message type definitions to owned. Okay, let's see if it likes to build that. Nope. Expected reference whenever I, okay, so yeah, I said I wanted to try borrowing, so let's try borrowing. All right. And yeah, all right, it attempts to write those things, and file name contents. write file name to own with contents, and then print line contents to owned, and then put a couple new lines under it. To owned. Apparently doing to owned on strings is a thing you do all the time in Rust. It's just the way it is. Hooray, that's what I wanted to see. So now I can try and do some string templating. Maybe we can do that in the next 10 minutes, then I'll call this episode done. So like IPC message start has this like structure to it. That looks like that. And this is what we want to put inside. I wonder if there's like a good indenting library. I guess it doesn't matter. Like, how do I do Rust strings, multi-line strings? How do I write a multi-line string in Rust? Multi-line string literal. So it's the leftmost non-space character is the first column. Maybe this is why I want raw string literal notation. Return equal return R. So I have to like let template equal R that, and then like that, and then I can do it like this. And then what if I return just the template to owned? What you say? What you say? Come on. Come on. Yeah, all right. So IPC message start now has that string. That's great. Now we're going to start inserting stuff into it. Does Rust have template strings? Core format. I guess it does. Flexible template engine for Rust. I don't really want to like do anything too crazy. We want to keep this like really simple. But maybe there's like a really cheap Rust template engine. Templating in Rust. Handlebars. It's pretty good apparently. Handlebars iron. File time. HTML templates. Mod. Liquid templating language. Templating horror show. That sounds great. Mustache. Twig. Poly. Terra. Okay. Handlebars. Take me to your leader. Where is it? Home. Mod. And horror show. And Rustache. Handlebars. Now, how big is it? It looks pretty complicated. I don't need anything too complicated. That's the thing. I want something small, super small. Compile time engine. The runtime footprint small. Mod runtime library including integrations less than 100 single lines of code. Oh, requires a nightly compiler and longer compile times. We don't want that. I don't want an HTML templating library. Flexible template engine. Render file. That's interesting. I don't want to do a whole lot of file I/O though. Rust string formatting. So maybe I'll just do string, like the built-in formatting. Formatting. Format. I think I want like named. Named. I think will be a lot easier to understand. Core format. Value. Yeah, that's what I'll do. Mustache value. Or curly braces value. So it'll be like mustache generated code warning. And then we want here the indented messages, right? With commas. So then I should be able to do return format template to own, or template, and then a set of arguments. Generated code warning equals generated code warning. And then like indented messages equals 1, 2, 3, 4, 5. I'll just do that for now. Let's see what you think about that. Now what you think about that? Now you know how I feel. Format argument must be a string literal. Oh no. Shoot, I don't want it to be a string literal. Format argument must be a string literal. I don't want it to be. I'll fix this is to replace print's definition. Stringify. Format with a non-literal string. That's what I exactly want. There's an unstable API for the parser here. I just use stir replace. Dot replace. Place first end method. Oh, man. Method replace. Rust simple string templating. Man, I was hoping this would be really easy. I want something small. Terra? No, I don't want like all the fancies. String template. Rust string template. Uh, maybe I can bite the bullet and say format, or there's got to be Rust string format multi-line. Rust reference. That's not what I want. Maybe I need some help. I'm gonna ask. Luxio TV wants to know what I'm making. I'm making an IPDL compiler in Rust. And if you're curious to know what that means, I recommend that you go back to the very beginning of this episode whenever it's done, and I happily explain it more or less at the very beginning. I'm going to join the Rust channel, and then maybe I can ask for some help. So join the Rust IRC channel. I'm going to ask for help. Gonna ask for help. That's what you do when you need help. It's okay to ask for help. I'm pinged someone who might know about this. I want, maybe instead of string template, I want Rust string interpolation. Dynamic string interpolation is kind of what we want. Wish list, functions with keyword args. Trying to figure out how to put strings together in Rust. Come on. No help yet. So let's keep looking. Rust multi-line string interpolation. Yeah, that's great if I've got like literal. Can I pass Rust, pass multi-line string literal? Maybe. Maybe if I just do like format that. So I'm going to take that out, get rid of this let template thing. Will that compile? Nope. Also nope. String literal with a suffix is invalid. I need like super simple Rust fast template. Compile time HTML, and I don't want HTML templates. Fastest template engine in the West. Smaller is better. Mod and horror show were quite low. But I don't want an HTML one. Fast string template language. Fast string concatenation. Type safe compiled Ginger-like templates for Rust. Super simple templating language library for Rust. That sounds good. Let's go back to horror show. And then what else do we have? I don't want power, I want speed. Compile time. Okay, Edo. What is Edo? Let's go to the home page and look at the documentation. Bring in Edo. We construct a template. Oh, that's nice. And how big is it? Not too big. That's not so bad. And what's the license? MIT? You're speaking my language. So maybe that's all I need is Edo. Edo. You pass in a string and then you register static. Very simple templating language. That's good. Handler function also accept arguments. So simple handler, handler with arguments. Oh, so you could like register like little functions. Don't want to do that necessarily, but okay. Template. Okay, let's try Edo. Let's try and bring in Edo. Let's try and get that to work, and then I'm gonna call it a day. So to do that, I go over to cargo and say that there is a dependency on Edo equals, and then what's the most recent version? 030. That's what I'll add. And then I'm going to bring in Edo. Use Edo. So in compiler, I'm going to say use Edo there. And then I can say let mute template edo stir equals edo new, and then I'm going to pass it our template. And then I'm going to call register static. And I'm going to say generated code warning. And generated code warning. And I'll do the same thing for indented messages. I'm just going to pass in like list of messages to owned. And then return template.render. Now render takes, what is that argument there? Render. Okay. Just render to owned. Render returns a string. Okay, so let's try that. Will you build with that? So it's going to go get edo now. Compiled edo. Didn't know what generated code warning was. That makes sense because I haven't actually declared it. Const generate code warning. And then say a reference to a static string that is the string, what was it? Code generated by IPDL parser. Actually, I'm not going to put that as a static up top because most of the time what we're going to want to do is put in the name of the file that caused us to generate. Like these two are special. The message start header and the message type defines are kind of special. I'm going to so I'm going to say generated. I'm just going to put these in like that. List of messages. Maybe missing extern crate edo. That could be. And then I think I have to put that over here too. Don't I? Main extern crate edo get ops. No, I guess not. Okay. Oh, I need it over here. Sorry. Extern crate edo. Maybe I'm missing. What? What? Extern crate edo. Maybe I'm missing in compiler.rs. It's never heard of edo before. Maybe I can search GitHub for extern crate edo. Yeah. Whoopsie daisy. Noise, noise, noise. So Rust. Nope. Extern crate tor desk. Use do it like that. Do you mean self Ito Ito? Extern crate. And what's wrong with this? Do you mean unresolved import Ito Ito? Wasn't the unresolved import? You need to write mod A if you want to use in your whole project. So maybe it's because I need to. Is there another place where I do an extern crate lalor prop util? Is there another place in here where I do extern crate lalor prop util? IPL.rs, parser.rs. Oh, maybe this is like use self. Okay, so like use self Ito Ito? So that's what I did here. Extern crate. Okay. Okay, well that's better. Expecting no type arguments. So let mute template. Let's get rid of that. Maybe it's enough to infer what I need. Yes. Seems to like it. Now let's see if it works. Code generated indented messages. What? Why didn't it render it? Like, it rendered everything until my template string, and then it screwed up. Why? That's like, you've got one job to do. What's...
I don't think so. Hey, what happened?
Weird. Why is it not... Template render. Is there like a maximum size template? Like, what's the dealio here? This is not the thing I expect to get tripped up on. What? Oh, oh, I know what it is. Yes, I think Dennis is also seeing it. It's the curly. Yeah, yeah, yep. We saw it at the same time, Dennis. It's the curly. Son of a bitch. Maybe, oh, that's gonna be a pain in the ass. Oh, that's gonna be such a pain in the ass if I have to escape all of these curlies. I'd rather have like a different. Ugh. I'd rather have a. Am I gonna have to write my own templating module? Grr. But good call, Dennis. Good eye. Good eye. Thank you. This is why I live hack, so other people can find my bugs. Nah, see, it doesn't like it. You can't escape. Folks, Ito is not the solution. I'm gonna get burned like crazy trying to use that. Ito is not the solution. Um, shoot. Shoot, shoot, shoot. Well, it's 2:51. I'm gonna see if anyone in Rust has an opinion about this in the Rust channel. Um, and actually, I'm also going to remove the Ito library. That's clearly not going to work, so I'm going to get rid of the Ito library stuff that I added. Don't need Ito. Don't need Ito anymore. I don't need Ito here. And I don't think I added it anywhere else, so that should build. Meanwhile, who in here would know what I want to know? JDM? Suppose I'm writing a hey folks, suppose I'm writing a function, a tool that takes in some AST and spews out some generated C++, where most of that generated C++ is pretty boilerplate and unlikely to change. How do I, is there a super simple templating library I can use to inject the non-boilerplate stuff into my strings? I don't. Alternatively, can I just use format? Didn't mean to use interrobang there. I meant the format macro. Because I said format exclamation mark question mark. I don't want to bring the chat onto the screen. You can't see what I'm writing. I know that. I don't like to chat with people in IRC unless they're like they give their consent. So I'll wait until someone responds and I'll ask if I can like drag the chat onto the screen. Like format with named variables is fine, except that it expects a string literal, and I don't know how to pass a multi-line string literal to format. Any suggestions? All right, so I'm gonna give people a minute or so to come up with something to give us a way forward, and if that fails, I'm just gonna end the episode right there. I actually think we got pretty far along. We made some headway, more headway than I think we made in past episodes on this particular project, which I'm pretty pleased about. There are a number of template libraries. Hey, DGC. Yeah, been browsing through them. Some of them seem a bit heavyweight for what I'm looking for. I'm trying to optimize for compile speed if at all possible. So the smaller the library, smaller and simpler the library, the better. Template engine, handlebars, liquid. And Umbrage has another suggestion. Whoa, what am I looking at here? This is just some paste. Multi-line should be as with normal. So apparently multi-line should be usable, passed into format. So like if I say return format indented messages equals test.toOwned. Will that work? And then toOwned. So they're saying multi-line strings would work as well. Interesting, because Rust is complaining when I do this. Paste. Hang on, paste bin. Am I somehow declaring my multi-line string incorrectly? Complains that error string literal with a suffix is invalid. Also, pardon my ugly Rust. I'm new at this. Aha! So, I've been given... Oh, I need to use a backslash before... Oh, interesting. Need a backslash. Tries that. Okay, so apparently I need a backslash right here. And then... Do I even need that first toOwned? Let's see. Oh, and then what else did they put in? They put in like R pound pound. I don't know why that is there, but then I put pound pound at the end of the string. Aborting due to previous error, cannot compile. Expected close parentheses. The important parts are pound pound. Let s equal... Oh, hang on. Let s equal format r pound pound toOwned. that. Expected one. Oh, am I missing a semicolon? Doesn't like expected close parentheses, found open parentheses. Huh. Oh, well, first of all, that shouldn't be here. But there's no way that that is complaining about it. So it seems to take the multi-line string now. Which is good. Doesn't seem to like my built-in curly braces that are not string literals. Or sorry, not not string literals. I mean, not meant to be formatted. So puts so can I share this? Share. How do I share this? Share. Just seb k. So I guess there's no choice but to escape it. I can't like ask Russ to use some other way of interpolating the strings, like, or something. So apparently I can escape using double curly like that. That's going to be a pain in the butt though. Yeah. Right. Okay, that appears to work, but it means if they are not part of the format string syntax, that's going to be a bit of a pain. Remembering. Okay, that works. Thanks. There's no way to modify that, right? Like, I'd love it if my strings didn't need to be modified where it's using braces in the non in the boilerplate C++ stuff, and only interpolate at a more uncommon pattern in the string, like, or I'm guessing saying that's not something I can do out of the box, and if so, is there okay, well, let's take a look. Hooray, we generated the right stuff. It put in the word test, and that's what I expected from here. Indented messages as test. So that's a pain in the butt. Okay, and I also have to go because apparently I have a meeting now, although I'm pretty sure I don't have a meeting. I'm pretty sure that my meeting starts in half an hour. Oh, no, he's right. Okay, I gotta go. Thank you so much for watching episode 91 of The Joy of Coding. We did a lot of Rust stuff, learned a bunch, and hopefully you enjoyed it. Hopefully that was useful to you. Thanks again for watching. Please rate this episode. There are links all over. There's one in the agenda. There's one in the video description. Rate this episode. Let me know what you thought. I'd love to hear about it. I read all of the feedback, so do let me know. Take care. I'll see you next week. Bye-bye.
The joy of coding.
See ya.